Hello guys, once again welcome back to my YouTube channel. So myself is Pavni Raj from Shri Venkateshwara College of Engineering. So today in this section we are going to discuss on a theory of a computation. So we'll be discussing on the Clean's theorem. What is a Clean's theorem? Clean's theorem is a foundational result in a formula language and automata theory. It establishes an equivalence between regular expressions and finite automata, showing that both describe the same class of languages known as regular languages. So, statement of Clean's theorem. Every regular expression corresponds to a finite automata that recognize the same language. Every language recognized by a finite automaton can be represented by a regular expression. This equivalence proves that a regular expression and finite automata are equally expressive. So now let us look at the proof for a structure for an Clean's theorem. First, part 1 will be the regular expression to a finite automaton. Construct a non-deterministic finite automata, means NFA, for a given regular expression. Then use a structural induction on the components of the regular expression. For the basic operations, union, concatenation and the Clean's star build corresponding NFAs. Then combine these NFAs using an epsilon transitions. And the next second step will be the finite automaton to a regular expression. Convert the given finite automaton into an equivalent regular expression. So remove the states systematically using a state elimination method and to drive into a regular expression for the language recognized in the automaton. Then identity rules. So there are the certain set of identity rules. The first is the epsilon into r or r into epsilon will be an r, and the pi plus pi into r or the r into pi will be an a pi. So epsilon star and it will be an epsilon, wherein a pi star will be an epsilon, and the fourth identity is then a pi plus r or r plus pi will be the r itself. Then again r plus r will be an r, and the sixth identity will be r into r star is an it gives an r star as an output. Seventh identity is the r star or the and whole star represents as an r star, and the eighth identity is an r star into an r star will be an r star, and the ninth identity is an epsilon plus r into r star, means r into r star will be represented as an r star as we seen in the sixth identity rule. So epsilon plus an r star will be set as an r star. Then the 10th identity rule, epsilon plus r star will be an r star. So epsilon plus whole r star will be also represented as an r star itself. And the 12th identity rule will be an epsilon plus r into an r star will be represented as an r star. And 13th identity rule is an r plus epsilon and the r plus epsilon star and r plus epsilon. Here r plus epsilon is said to be as an r, then again r plus epsilon whole star will be set as an r star, and again r plus epsilon same it will be set as an r. So r into r star, again r will be set to given as an r star. Then again r star plus s, r star s plus s will be set as an r star s. Then again pi plus epsilon will be set as an epsilon. So this is an Clean's theorem formula. The formula should be as an Rij whole power k is equals to Rij k minus 1 plus Rik k minus 1 and multiply by Rkk whole power k minus 1 whole star and Rkj k minus 1. So this is a formula we'll be using on the problems by using a Clean's theorem formula. So the final will be in a conclusion part. Equivalence of any representations. Clean's theorem establishes the equivalence between regular expressions and finite automata, means NFA and the DFA, proving that both describes the same class of regular languages. Theoretical significances. The theorem bridges two perspectives of regular languages. First is the declarative. Regular expressions describes the pattern in a concise, human readable form. And the second is the constructive. Finite automata provide an algorithmic way to recognize and process these patterns. Then let us go for the application parts. So foundational in compiler design for lexical analysis and essential in understanding and designing the text search algorithms and pattern matching tools. Then the key to take away is an Clean's theorem reinforces the power and flexibility of formal language theory, showing that logical descriptions of patterns and their mechanical implementations are initially linked. Okay, thank you guys.